Okay, let us look at your Thermophysics class test 2, question 1. In question 1, the graph below shows the variation of temperature change, delta theta, with time for 1 kg of substance, which is initially at solid at room temperature. You are also told that the substance is heated at a uniform rate of 2000 joules per minute. Then you are given 4 statements and you ask what can be deduced from this graph. To look at which statement is correct, let us first analyze the graph. We can see that in this graph, in the first phase of the graph, it undergoes temperature change, and since you are told that the question starts off, the object starts off as a solid, this should be going off at a solid, and from here we can see that it is undergoing just simply a temperature change. Then for the next few minutes, we can see that this plateaus out, and this means that what is happening, that this is actually starting undergoing a melting, and we can see that it should initially be a solid, and then it would have completely melted at the 7th minute. Okay, then finally it should be in the liquid phase, and it is actually gaining temperature. So there are actually 3 stages, stage 1 and stage 2 and stage 3 that we can look at. So let us look at statement A. In statement A, you are told that after 4 minutes of heating, the substance is all liquid. So if we look at this particular point, which is at 4 minutes of heating, we can see that it is actually starting to melt, and so it's still all in solid phase, so it is not a correct statement. And in B, you are told that after 10 minutes of heating, the substance is all gaseous. We can see that this object, it has not gone through another plateau region where it's actually going to become a gas, so this is also not true. The specific heat capacity of the substance is greater when liquid than when solid. To look at this particular, we need to compare the two regions in region 1 and region 2. So let us look at the specific heat capacity when it is in liquid phase, and see how we can get specific heat capacity. Now in the question, you are told that you are actually going to heat at constant rate. So what we can say is that the power supplied is actually constant. So we're going to heat it for a period of time of delta T. So we can also see that for the same mass change, that is going to cause a temperature of your Thermophysics class test 2 question. You are given a substance graph that shows the variation in particular substance. You are also told that it initially starts off as solid at room temperature, and there is a constant rate of heat that is actually supplied at 2000 joules per minute. Then you are given 4 statements and you are asked to choose what can be deduced from this graph. So to particularly understand this graph, it may make sense to actually try and understand this particular graph in the first place. So basically we see that the graph can be broken up into 3 stages. We are told that the question starts off at solid, and so this is the point where it actually increases from room temperature to a particular temperature at the 4th minute. Then you have a flat region. What it simply means is that melting is taking place, and so actually converting into a liquid at a constant T. It stays at liquid and gains temperature. So in this flat region, it is actually both a combination of liquid and solid. After 4 minutes of heating, the object is still going to stay at a solid phase, and so A is not an option. You can also see that after 2 minutes of heating, the object is still going to be a liquid, so B is also not an option. Let us look at C, the specific heat capacity of the substance when it is liquid than when it is solid. So to analyze that particular statement, we need to analyze stage 1 and stage 3 of that graph. So you can see that actually the key difference between the two stages are actually in the gradient. So if we can see how the specific heat capacity of the substance, how it's related to the gradient, we will be able to do this particular question. So to get a gradient, the gradient of the graph is given by d theta dt. So if we can find a relationship that relates theta, t, and specific heat capacity, that would be what we would be looking for. So you are also told in the question is that the substance is heated at a uniform rate. So what we can say is that the power supplied is actually constant. So we know that there is actually some power supplied over a particular interval of time, and that will cause the substance in both stages to increase in temperature. So we can see that C is actually can be manipulated. Let us put all the constants together and write P over M, and that is equals to 1. Let's keep our delta theta over delta T together. And of course, for very small changes, we can also write that as 1 over gradient. Hence, we can see if your gradient is larger, your C will actually be smaller. Okay, so if you look at stage 1, you can see that the gradient is less. The gradient is less than the gradient of 3. So the specific heat capacity in the first stage is actually larger than the specific heat capacity in the third stage. So the specific heat capacity when it is actually in solid phase is actually larger than when it is in liquid phase. So this is a false statement. Okay, now let us look at part D. For part D, to find the specific latent heat of fusion of the substance, basically we look at stage 2 during this constant phase. Again, by using conservation of energy, the energy supplied will go into melting the liquid. So it goes into melting the liquid. So from here, we can get the specific latent heat of fusion. This is done over 3 minutes. So from there, you can get PT over M. According to the question, it is 2000. Joules per minute. and the time interval is 3 minutes, and according to the question the mass is 1 kg, and that will give me the answer. So D is the correct answer.